Hello everyone, welcome to my channel Middleware Technologies. So in our last couple of videos, we have seen how we can build a messaging application using NATs, and we have seen a couple of features such as how we can load balance traffic using queues and how to persist messages using Jetstream. But there is one thing that we haven't looked at, that is clustering. So here in this video, like we will see like how we can build a fault tolerant and highly available cluster using NAT servers. So here in this article, we will try to build a cluster of three NAT servers, which will help us in providing a fault tolerant and highly available clustering feature. So we will see like how we can implement that in this video. So coming to my test environment, I'll be working on Fedora 41 server, and I have the NAT server binary and the NAT CLI installed on that server, which we'll be using for this demo. So before getting into the details of how we can implement a cluster of servers using NATs, let us try to understand what is NAT's service infrastructure. So NAT's messaging platform is basically a client-server architecture wherein NAT's client applications, basically the client applications, leverage the NAT's client libraries to connect to NAT server. So it's basically a client-server architecture wherein clients use the NAT's client libraries to connect to NAT server. NATs is extremely flexible and scalable and allows the service infrastructure to be as small as single process running locally on your local machine or as large as Internet of NATs. So let us try to understand this statement. So NATs is flexible in how you can deploy it in your environment. Like you can deploy it as a single server, single standalone server running on on your local machine, or you can deploy a set of servers which form a cluster, and these clusters can be deployed in multiple regions, basically forming a supercluster. So that is what NAT service infrastructure is all about. So you can build from a single node server to a multi-node cluster that is spanning multiple regions or multiple virtual private clouds in a cloud environment. So NAT service infrastructure can be built by deploying the cluster of NAT servers in multiple locations and multiple cloud providers and VPCs. So as I mentioned, you can deploy NAT servers in a cluster, deploying it in multiple locations or regions or virtual private clouds. But the only configuration that is needed by the client side is the location of the NAT's URL of one or more NAT servers, and depending upon the security that is configured, they will need credentials for connecting to that server. So that is all needed by the client applications to connect to a cluster of NATs servers. Now let us try to understand how a NATs server clustering can happen. So NATs supports running each server in cluster mode. So the servers that form a cluster establish connection with each other using the gossip protocols. So let us say like if you have three servers, if you enable all those three servers in cluster mode, they will try to discover each other and establish connection with each other through a gossip protocol. So gossip protocol, basically also known as rumor protocol, is a communication mechanism used in distributed systems where nodes exchange information with each other in a decentralized manner. So they are the clustered nodes, like they try to exchange information about each other, like what they know about the other servers like that are in nearby vicinity in that cluster. So each NAT server instance will only forward messages that it has received from a client to the immediately adjacent NAT server instance to which it has a route. So it supports only one hop. So a NAT client is able to send a message only to a NAT server that is just adjacent to it in a single hop. Messages received from a route will only be distributed to local clients, and also like whatever messages you receive through a route that is a part of a cluster, like that will be sent to the clients. For the NAT servers to form a full mesh, each server should be able to communicate with each other, and also each client should be able to connect to each server in the cluster. So this is a requirement. If you are trying to form a cluster of 3 servers, all the 3 servers should be able to communicate with each other, and all along with that, the clients that want to connect with those servers, they should be able to connect to those 3 servers that are trying to form a cluster. So that is all about NAT's server clustering. Now let us try to understand the high level architecture that we are going to implement in this video. So here in this demo, we will try to set up a cluster of three servers to form a NAT service infrastructure, and try to connect PubSub clients, that is publish or subscriber clients, to these cluster members, and demonstrate the fault tolerance, high availability, and scalability features. So we will try to see like how we can form a cluster of 3 servers, and how we can have the clients that are publishers or subscribers connected to the servers that are a part of a cluster, and how they are able to communicate messages through the cluster members. And we will see like how we can scale up or scale down the cluster members, and see how fault tolerant like our cluster is able to manage fault tolerance, like when a cluster member gets down, like how it is able to route the messages by distributing with the other cluster members that are available in the cluster. So this is the high level architecture that we are going to implement. Now let us go to our procedure, like how we can implement the cluster. So as a first step, we need to create a seed server A. A standalone NAT server, basically like whatever demos we have done is we have done it with like NAT servers in a standalone mode. So in a standalone mode, like we have the NAT server listening on port 422 for the client's connection. But for a NAT servers to be able to form a cluster, to be a part of cluster, it also needs to listen on the cluster port or cluster URL. So here, like we will launch our first member of NAT's cluster, which is also known as seed server. So so here, like we will be setting up this seed server, but instead of using the NAT's CLI, like whatever parameters that we can pass through NAT CLI in order to set up the cluster, we can do that using a configuration file also. So in this demo, like we will be trying to use the configuration file. We will leverage the NAT's configuration file to pass our server configuration as shown below. So we will try to see that shortly. So let us try to understand the configuration file first. So let me go to my shell. So I have my server configurations already available. So let me try to open the server configuration for the seed server. So this is a very basic configuration file that we can build. So here you can see this host and port is going to be the client listening host and port on which the server is on which the server is exposed. So basically, the clients can connect to the server on the following port with the following hosts. This host can be any interface. And we are providing a server name also for this demo, like we are providing our seed server name as server_A. Now coming to the section of accounts. Here, like what we are basically doing is we are creating a user with a password admin, and this user we are adding it to the account $sys. So $sys is basically a specialized account in NATs which provides administrative privileges to the client who uses that user, in this case the admin user, to connect to the server. So this user basically can do administrative work on the servers, like managing the cluster members or the servers in a cluster. So that is all what we are doing with this accounts configuration. Now let us go to our third configuration part, that is cluster. So in order to convert, in order to make a NAT server to be clustered, to run in a clustered mode, like we need to enable this definition, that is a cluster definition, wherein we will be passing the name of the cluster and the host, or the host on which the cluster is going to talk, and the port of the cluster. So this is basically the host and port forms the listening section for the cluster. So this cluster member can talk or listen on this following host or port. And similarly, like we will be trying to do the same cluster definition setup for all the other servers. So this is the very basic configuration file that we are going to use in order to launch our seed server. So let me close this one. Let me clear my screen and let us now go to our documentation. So we have already looked at the configuration file and we have looked at the sys account, the importance of sys account, and we also have seen about the listening port for the listening port for cluster and the client connections. So we have just try to understand what exactly we are doing. And one thing is important, like in this demo, like I'm setting up a cluster on a local setup. So we will be just updating the ports for the client connection and the cluster URL to be unique so that they do not conflict. So here is the configuration file for server A, that is we have already seen. So once your configuration file is ready, we can launch our server by passing the configuration file as shown below. So let us try to launch our server with this configuration file. So we'll use the NAT's server binary and pass the configuration file, that is server_a.conf, using the -c option. Let us start our server. So you can see the server is a part of cluster_demo, and it is using the configuration file server_a.conf, and it is listening for the client connections on the following host and port. And it is the cluster name is cluster_demo, and it is trying to look for route connections on the following port, that is 4248, which is the cluster listening port, we can say. Okay, so this is our seed server is now up and running. Now let us go to our next step, that is step 2, create a cluster member server B. So like how we have done the setup for server A, like we will be doing the same thing for server B, but there is some small change in server B that we will be taking a look at it. So let us go to our next shell. And let me go to NAT's cluster wherein my configuration files are available, and let me open the serverb.conf file. So here, like you can see, all this general section is same as what we have done for server A, and the account section is also same as what we have done for server B. The only thing that we are changing is the cluster definition for server B. So here also, like the name, the host is same. The port we are going to change it to 5248 so that it does not conflict with the 4248 port for the cluster A. And additionally, like we need to define the routes. Basically, routes provide information about how this cluster member is able to communicate with the seed cluster. So this is the seed cluster URL that we have configured in the routes. So this server forms a cluster by trying to establish a connection with the seed server on the following URL. So this is the very basic configuration that we can do for our cluster member. So let me close this file. And now once your cluster member B server configuration file, server's configuration file is ready, we can launch our server with that configuration file. So here, like I'm using the same NAT server binary, and passing the config file server_b.conf file to this option. So let us try to launch this server. So now you can see the server has launched and it is using the server_b config file, and it is listening for client's connection on 4223 port. And along with that, it is listening for route connections on 5248, and it has created a route or established a connection with our seed server that is listening on the following port 4248. So this is how your server B is able to establish a connection with your seed server and form a cluster. Now let us try to add one more server to our cluster group. So let us go to our next step, that is step 3. So here also, like, what we are going to do is we are going to create a cluster member server C. For that, let us go to our next shell, and let me go to my NAT's cluster location where I have the server_c conf file. So here also the general configuration is going to be same, like we are just updating the port number to 4224, and in server B the port number is 4223, and server A it is 4222. So all the three ports are unique, and we are providing the server name as server C. The account section is going to be the same, and in the cluster section, like we are providing the cluster name as same. The host is localhost, and the port for this server C cluster is going to be 6248, and it is going to try to establish a connection with the seed server that is listening on 4248. So this is our basic configuration file for server C. Now let us try to launch our server using the configuration file, that is server_c.conf file. So you can see the server is launched and it is listening on the following URL for cluster route connections, and it has established the connection with it has established the connection with our seed server. And also, if you see our servers, like they have formed a mesh now, like they are able to talk to each other. You can see it has already established a connection with server A, and now it has established a connection with our server C also. So this is how a mesh of all the three cluster members is created, and they are able to communicate with each other. So once our three clusters are ready, now it is time to test our cluster. So let us go to our next step, that is step 5, testing the cluster. So here, like what we will be doing is, let me go to my demo, like high level architecture that I have built. So we have our three cluster member running, and now what we will do is we will launch a publisher and subscriber. Both are connecting to a different server. So let's say the publisher will connect to server A and the subscriber will connect to either server C or server B, and we will try to send or publish some messages onto the following subject, that is hello nats, and this message is going to be routed to the appropriate subscriber that is listening on a particular server URL. Okay, so it works seamlessly. Like you need not worry about where your like how is your message going to be delivered to the appropriate subscriber. That is all taken care by the cluster. So as soon as a message is received on this particular subject, it will be routed to the appropriate subscriber that is subscriber to the cluster member, and it will receive that message. So that is what we will be trying to test it. Let me go to my step 5 again. So now what we will do is we will try to first launch our subscriber that is connecting to the 4223 server URL. So this is basically server B. So our subscriber is connected to server B. So let me go and open another shell, and here let us try to launch our subscriber that is going to listen on 4223 port for messages. Now let us open another shell wherein we will launch our publisher. So here, like, we will try to publish messages from different cluster members. So let us try to do it one by one. So here, like, I'm trying to first publish my message using the server that is 4222, that is server A, and we are sending the message on hello.nats, and this is our message. So let us see, and you can see the message has been published, and you will see on the listening side, that is on the subscriber side, the subscriber is able to get this message even though both the publisher and subscriber are connected to different servers. So that is how the subject based messaging works in NATs. Now similarly, like, let us try to publish messages from different server, that is server B. So you can see the message has been published, and now let us try to send another message using the third server that is listening on 4224, and it is going to send a message hello from server C. So you can see all the three messages have been delivered to the subscriber that is listening on server B. So this is how the subject based messaging works. So we have seen like how the messages have been received. Now let us try to publish messages from the NATS client by pointing it to all the NAT server URLs in the cluster as shown below. So now what we will do is we will try to publish the message by connecting our client, that is NATS client, to all the server in a cluster. So it can take any it can establish connection with any of the cluster member from these three URLs. So let us see how it runs. So you can see it has executed, it has submitted, published our message, and you will see it has received the message from NATS cluster member. But how do you know like which cluster member has sent this message? So that we can do another watch. So we can do watch on NATS server ls sort by name. So this is what our servers clusters look like. So we have three clusters: server A, server B, server C. They are all a part of cluster, that is cluster underscore demo. And we have established there are two connections right now, that is you can see the connections are switching from server A to B to C. So that is how the connections are like established with the server members by the clients. So now let us try to send a message now again. So this message will be delivered by one of the cluster members from this cluster underscore demo cluster. So this is how like we will be able to seamlessly route our messages through the cluster members which we have just created. Now what we will do is so let us go to our next step, that is step 6. Like here, like what we will do is we will create and switch to a particular client context. So basically until now, like what we have seen is we have manually triggered the NATS client to connect to a particular server and trigger the messages. But instead of doing that manually, you can configure that using a context. So let us try to create a context, that is NATS context save cluster underscore demo. So this is going to create a configuration file, that is this one, and these URLs, like I have already added it, but this we need to add it by editing the context. So this is how like you will be able to edit the context, and you can add all the three servers that are forming a cluster. These are the cluster server URLs that we will be configuring in this URL section. And also, like, we will configure the user with which this NAT CLI is going to connect. So this is the user with which we are trying to connect to the server, and this user has administrative privileges because we have already added this user as a part of sys account. So let me save this one. So we can save that changes. Once that changes are done, you can just switch to that context so that you will start using that connection details. So we have switched to that connections, and now you can just publish the messages onto the subject hello.nats, and let us say hello from context, or any message you can send it. So you can just say that, and it will try to establish a connection with the servers in the cluster, and it will send your message. So here is the message that we have received through the cluster. So this is how clustering works. And now that we have tested, we have created and switched it to the client context. Now let us try to see what is the admin user work that we can do with in this demo. So in this step 5, we will try to validate the cluster's admin user. So by default there is an implicit system account created on the server, so that is $sys, but there are no users associated with. So by default there is a sys account, but there are no users that are added as a part of that account. As we have enabled the client to connect with admin user who is a part of sys account, this system account enables for operations and monitoring the server, cluster or supercluster. So as in our server configuration file, we have already added that user to the account $sys. We gain privileges of the system administration, so we can do all the operations and monitoring on the servers, cluster or superclusters to which we are connected. Now let us try to do one of the administrative tasks, that is pinging the servers in a cluster. So you can see, like, you will get a response from all the three servers, and this is the round trip time that has taken to get a response for your ping from all the three servers. Okay, so now that we have our this is how, like, you can use the admin user. There are other administrative stuff that you can do, but this is very basic thing that I have shown you. Now let us try to so we have already looked at NAT server ls. So it provides us with a list of all the servers that are available in the cluster, and this is our cluster with the 3 node, and we have all 3 clusters which are in the group. So now we have looked at how we can create and switch to the context, and we have also looked at how we can validate the cluster's admin user. Now let us go to our next step, that is step 6, simulating the PubSub messaging traffic. So here, like, what we are going to do is we are going to simulate PubSub messaging traffic using the NAT CLI. So first, what we are going to do is we are going to use NAT's bench command. So let me go to my shell where I have the subscriber launcher. So here, like, what we'll do is we will launch a set of 10 subscribers that are listening on hello.nats using the nats bench. So this is going to create 10 subscribers that are going to receive messages on hello.nats. Now what we will do is we will try to send messages using the publishers onto that subscribers. So you'll see we are using the nats pub, and this is the subject on which we are sending this message, and the count option is -1. So we will be sending infinite messages with a sleep interval of 10 milliseconds until we stop. So let us launch this. So this is sending the messages, and you will see it is receiving the messages. Now what we will do is we will first try to see NAT server ls. So you can see like the connections are getting established, and let me do it in the watch NAT server ls, and you can see the connections are getting established with the servers, and they are serving the requests. Now we will what we will do is we will try to kill one of the server. Let's say like we are trying to kill the server A, and let us try to monitor, and you can see that the server B and server C are still serving the publish subscribe messaging clients. They are able to distribute the traffic along uh, through those two servers. So that is how like fault tolerance is achieved, and we are able to see like all the, if there are three servers, all the three servers are getting distributed with all the traffic. So with that we are achieving the high availability also. So now if I try to start this server again with the same configuration, that server will again re-establish the connection, and that will be that will be connected to the cluster again. So this is how like you will be able to demonstrate how the fault tolerance and high availability features are supported by this NATS cluster. So you can, so as I said, like you can try to launch some more servers by creating a config file and try to see if they add to the cluster, and also try to shut down a server and see if the pub/sub messaging still works with the servers that are available in the cluster. So that we have already seen. So this is a very basic demo that I could show you, like how we can use the NATS clustering feature to establish a cluster of servers in a particular region, and you can like basically create a cluster of clusters forming a super cluster that connects to a backbone a NAT server, and you can do all the messaging communication via those gateway connections or backbone connections that connect multiple different clusters. So this is what I wanted to show you in this video. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.